Hello there, and welcome to The Sleepy Scholar. Tonight's journey takes us into the quiet, complex, and ancient world of fear. We will explore this powerful feeling not as something to be afraid of, but as a remarkable story of survival, biology, and the mind. Fear is one of life's oldest companions, a silent guardian that has whispered warnings to every living creature, helping to shape the very path of evolution. It is a fog that rises from the deep past, a cold shadow that sharpens the senses and focuses the mind. Tonight, we will walk calmly into that shadow, holding a small light of curiosity. We will look at how this feeling is born in the intricate pathways of the brain, a cascade of chemicals and electrical signals that are as precise as a clock. We will see how it has etched itself into our stories, our myths, and our art. A shared human experience that connects us across all of time. This is not an exploration meant to startle, but one meant to understand. Each fact is a gentle step toward appreciating the profound and protective architecture that exists within all of us, a testament to life's enduring resilience. If you enjoy these quiet explorations, consider subscribing so you can easily return here whenever you need to rest. For now, get comfortable. Let your eyes grow heavy. Let's begin. The brain's fear center is a small, almond-shaped cluster of neurons called the amygdala. This structure rests deep within the brain's ancient limbic system, a part of our mind that evolved long before conscious thought. The amygdala acts as a silent, sleepless sentinel. It constantly scans all the information coming from our senses, what we see, hear, and feel, looking for patterns that match its vast library of threats. Long before your thinking mind has time to process a danger, the amygdala can recognize it and sound a powerful internal alarm. This signal is what initiates the cascade of the fight or flight response, instantly preparing the body for action. It is not a place of logic or reason, but of pure, immediate reaction. This small, elegant cluster of nerves is a profound inheritance, a guardian that honors its ancient duty to protect, a tiny, powerful echo of survival. The fight or flight response is an ancient survival mechanism that floods the body with powerful hormones. Imagine an ancestor standing in a quiet forest and suddenly hearing the snap of a large twig. There is no time for slow, careful consideration. The body requires immediate, overwhelming power. This is the stage the fight or flight response sets. The amygdala's alarm reaches the hypothalamus, which acts like a command center, signaling the adrenal glands. These glands instantly release adrenaline and cortisol into the bloodstream. The heart hammers faster, forcing blood to the large muscles of the arms and legs. Breathing deepens, pulling in more oxygen. Pupils dilate to let in more light. Digestion and other non-essential systems pause, conserving every ounce of energy for a single, profound purpose. To survive the next few critical seconds, this sudden, fiery awakening is a testament to the body's deep commitment to life. Before fight or flight, the most common first reaction to a sudden threat is actually to freeze. We often picture survival as a stark choice between running or confronting, but there is a third, quieter response that often comes first. It is the deep, sudden stillness of a deer in the woods that hears a strange sound. This freeze response is a crucial, often hidden, part of the fear sequence. It is managed by a different part of the brainstem, and it is, above all, an act of assessment. By becoming perfectly still and silent, an organism can avoid detection by a predator that hunts using movement. This pause also grants the brain a few precious moments to gather more sensory information, to pinpoint where the threat is and what it is. During this brief, attentive stillness, the heart rate may even slow down before the rush of adrenaline prepares the body for its next, more active move. Humans are born with only two innate fears, and one of them is the fear of falling. While we learn to fear many things throughout our lives, from spiders to public speaking, our minds do not arrive as entirely blank slates. Evolution has gently pre-installed certain fundamental warnings, wisdom gathered over millions of years of existence. This fear of falling, known as a prepared fear, is present in infants long before they have ever experienced a painful fall or been taught that heights are dangerous. This was famously demonstrated in visual cliff experiments, where babies who could crawl would hesitate to cross a glass surface that appeared to be a steep drop, even when their mothers encouraged them from the other side. This instinct is a powerful and necessary inheritance for a species that walks upright, a simple, profound instruction whispered from countless ancestors. Respect the emptiness below. The second innate fear shared by newborn infants is the fear of loud, sudden noises. Much like the fear of falling, this response is not learned from experience, but is woven directly into the fabric of our nervous system. From the moment of birth, it is a universal reaction, a startle that transcends all culture. This is often called the Moro reflex in babies, a sudden sharp sound, like a crack of thunder, or a predator's roar in the distant past, is interpreted by the brain's most primitive structures as a sign of immediate and significant danger. The sound itself does not cause harm, but it signals a potential event that could. The reflex causes the body to jolt, the arms to fly wide, and often a cry. This is the body's instant, unfiltered alarm bell, demanding attention and preparation before the conscious mind even has time to identify the source. Goosebumps are a lingering, ancient fear response from our much hairier ancestors. In a moment of sudden cold, or when a shiver of fright runs down the spine, a strange texture appears on the skin. Tiny bumps rise, and the fine hairs on our arms and neck stand on end. This seemingly useless reflex is a ghost, a quiet echo from a much more functional past. This reaction is called piloerection. It is triggered by a tiny muscle, the erector pili, which is attached to each hair follicle. For our distant, fur-covered ancestors, this reflex served two vital purposes. When cold, fluffing up the fur trapped a layer of air, providing insulation. When threatened, it made the animal appear larger, more bristled, and more intimidating to a potential predator. Though our sparse body hair makes this reflex ineffective today, the mechanism itself remains, a fleeting reminder of the wilder body we still inhabit. The brain can learn to extinguish a fear, but it never truly forgets it. Fear is a powerful and necessary teacher, but what happens when a situation that was once dangerous becomes safe? The brain has a remarkable process for updating its own warnings, allowing us to adapt. This is called fear extinction. It is important to know this is not the same as forgetting. The original fear memory, etched deep within the amygdala, remains. Instead, the brain builds a new memory, a competing memory of safety. This new learning is cultivated in the prefrontal cortex, the brain's home of logic and control. Through repeated, safe exposure to the feared situation, the prefrontal cortex learns to send an all-clear signal that quiets the amygdala's alarm. It is a delicate balance where the new safety memory actively suppresses the old fear memory. The mind is not a stone tablet, but a living manuscript, capable of writing new, calmer chapters over the old. A phobia is different from fear. It is a persistent, irrational response where the brain's alarm is stuck. We all experience rational fear in the face of genuine danger. A phobia, however, is a different creature entirely. It is when the fear mechanism, designed to be specific and temporary, becomes oversized, entrenched, and unmanageable. A phobia is a type of anxiety disorder where the feeling of terror is vastly out of proportion to the actual objective danger. The brain's threat detection system, the amygdala, has become hypersensitive. It forms a powerful, lasting association, linking a specific object or situation, like a high place or a crowded room, with a feeling of life-threatening danger. This connection becomes so strong that the logical mind, the prefrontal cortex, cannot easily override it. A phobia is like a devoted guardian who has become overzealous, seeing a profound threat in every shadow, a powerful expression of the mind's desire to protect. The fear of social rejection is processed in the same parts of the brain that register physical pain. For the vast majority of human history, our survival was not a solitary pursuit. We lived in small, cooperative groups, where inclusion was essential. Being accepted by the tribe meant access to food, shelter, and protection from predators. Ostracism was a death sentence. Because inclusion was so critical, our brains evolved to treat social rejection as a severe threat, on par with a physical injury. Neurological scans show that when a person experiences social exclusion, the dorsal anterior cingulate cortex becomes active. This is the very same region that lights up when the body feels physical pain. This deep wiring means that the anxiety of public speaking or the fear of being shamed is not a modern weakness. It is an ancient survival instinct, the brain's visceral reaction to a threat against its fundamental need to belong. Fearful memories are encoded more strongly and quickly than neutral memories. Our memory is not an unbiased, perfect recorder of all events. It is a tool for survival, and it selectively prioritizes information that will keep us safe in the future. It pays special attention to moments of high alert when the amygdala triggers a fear response. It also sends a powerful signal to the hippocampus, the brain's memory formation center. This signal essentially highlights the entire experience as being critically important. The accompanying rush of stress hormones, like adrenaline, further strengthens the synaptic connections that form this new memory. This is why you might forget what you had for breakfast 3 days ago, but you can recall a near accident on the highway with perfect, vivid clarity. A frightening memory is a story written in bold ink, a lesson the mind refuses to let fade, all in the service of a safer tomorrow. The Uncanny Valley describes a specific fear or revulsion we feel toward things that look almost human, but not quite. We are naturally drawn to human faces, finding comfort in their familiarity, but as an object, such as a highly realistic robot or a computer-animated character, gets closer and closer to looking human, we can suddenly feel a deep and profound unease. This sharp dip in our emotional response is the Uncanny Valley. The theory suggests that when something is clearly not human, like a simple cartoon, we accept it. When it is perfectly human, we also accept it. But in the space between, our brain's perceptual systems are thrown into conflict. The small imperfections, a stiffness in movement, eyes that don't quite focus, a lack of subtle expression, create a mismatch. Our brain detects something that should be human, but registers it as wrong. This can trigger ancient warning systems related to disease or death, creating a feeling of revulsion. The sense of smell has a direct primitive pathway to the brain's fear and memory centers. Our senses of sight and sound are sophisticated, but they must pass through several relays, like a switchboard, before being fully processed. Smell, however, is different. It is an ancient, more primal sense, and it takes a privileged shortcut deep into the brain. When you inhale a scent, the information travels from the olfactory bulb directly to the amygdala, the fear center, and the hippocampus, the memory center. This is why a specific smell, like that of a dusty attic or a particular antiseptic, can trigger an immediate and powerful emotional memory or a jolt of anxiety, long before you can consciously place what the smell even is. This direct link is an evolutionary relic. For early creatures, smell was the primary way to detect a predator, spoiled food, or a distant fire. It remains a potent, quiet messenger, speaking directly to our most ancient emotions. People can enjoy being frightened in a safe context, a phenomenon known as recreational fear. It is a strange paradox. Why would we willingly seek out an emotion that is designed to be unpleasant? We pay to ride roller coasters that simulate falling, or sit in dark theaters to watch stories that present a terrifying threat. The secret lies in the safety frame. When we are on that roller coaster, or in that movie theater, our conscious logical brain, the prefrontal cortex, is fully aware that we are not in any real danger. This knowledge allows us to experience the intense physiological rush of the fight or flight response, the pounding heart, the quick breathing, the flood of adrenaline, as exciting rather than terrifying. It is a way to play with our body's powerful survival instincts from a position of complete control. It is a way for the mind to safely tour its own defenses, to feel alive by gently touching the boundaries of its deepest alarms. The fear of the dark is a primal fear rooted in our reliance on vision as a primary sense. For many creatures of the world, the night is a time of advantage or safety, but for humans, we are creatures of the day. Our eyes are built for sunlight, for distinguishing colors and details from afar. When darkness falls, our most dominant sense is compromised. We become vulnerable. This fear, known as nyctophobia, when it becomes intense, is an evolutionary echo of a time when the night truly was full of dangers. Predators that hunted by sound or smell had a distinct advantage. For our ancestors, the blackness did not just hide the path, it hid active, unseen threats. The fear of the dark is therefore not a fear of the darkness itself, but a profound fear of the unknown that it conceals, the anxiety of our primary warning system being switched off. Music can skillfully manipulate our fear response using ancient biological cues. A film's most tense moments are often defined not by what is on the screen, but by the sounds we hear. Music has a unique power to build tension and trigger anxiety. Composers use several techniques that tap directly into our primal alert systems. Non-linear sound, like the sudden, discordant shriek of a violin. This sound mimics the frequency and structure of an animal's distress cry, which bypasses our logic and triggers an immediate, visceral alarm in the amygdala. Another tool is infrasound, very low-frequency sound that is below the range of human hearing, perhaps around 19 Hz. We cannot hear it, but we can feel it as a vibration. This low rumble, often associated with approaching natural disasters or large predators, is known to create a general sense of unease, anxiety, and even dread, all without us knowing why. The whites of our eyes, the sclera, evolved in part as a social tool to instantly communicate fear. If you look at most other primates, their eyes are dark, with the sclera, or the white part, barely visible. Human eyes are strikingly different, and this difference is a key to our cooperative survival. The high contrast between our white sclera, the colored iris, and the black pupil makes it incredibly easy for us to see precisely where another person is looking. This allows for gaze following. This is especially crucial for communicating danger. If one member of a group spots a predator, they may not have time to shout. A sudden shift of their eyes, revealing a wide expanse of white as they look sharply to the side, is an instant, silent, and unambiguous signal. It tells everyone else not only that there is fear, but where the threat is located, all in the span of a single glance. The widespread fear of spiders may be an evolutionary leftover from a time when they posed a much greater threat. For most people living in modern environments, spiders pose little to no real danger. Yet, arachnophobia is one of the most common phobias in the world. This disproportionate fear suggests its roots run deeper than personal experience. This is a concept known as evolutionary preparedness. The theory proposes that over millions of years, especially in our ancestral homelands in Africa, a quick, cautious reaction to spiders was a significant survival advantage. While most spiders are harmless, a bite from a venomous one could be fatal. Humans who possessed a spider detection template in their brain, a tendency to notice them quickly, were more likely to survive and pass on their genes. We may be inheriting this ancient, better safe than sorry policy. This lingering fear is a testament to the long memory of evolution, a cautious whisper from a time when small, eight-legged shadows were a genuine peril. During a moment of intense fear, time itself can appear to slow down. People who have survived life-threatening events, like a sudden fall or a car crash, often report a strange phenomenon. The world seemed to move in slow motion, allowing them to see events unfold with impossible, crystalline clarity. This is not a change in the physics of time, but a profound shift in the brain's processing of memory. It is an illusion created in hindsight. During the terrifying event, the brain's fear center, the amygdala, goes into overdrive. It commands the brain to absorb a massive amount of sensory detail, far more than it normally would. Later, when the brain reconstructs the memory of that event, it is confronted with this incredibly dense and detailed record. Because so much happened in those few seconds, the mind interprets the duration as having been longer. It is the mind stretching its own perception, weaving a richer story from a moment of pure survival. Courage is biologically distinct from fearlessness. It is the act of overriding the fear signal. We often imagine brave individuals as people who simply do not feel fear, but neuroscience reveals a different, and perhaps more inspiring, reality. True fearlessness is incredibly rare, and usually the result of brain damage to the amygdala, leaving a person unable to recognize danger. Courage, on the other hand, is an active process. Scans of a courageous person's brain show that the amygdala is, in fact, firing wildly. The fear is present, loud, and clear. However, another part of the brain, the subgenual anterior cingulate cortex, also becomes highly active. This region is associated with self-regulation and values. It effectively steps in, acknowledges the amygdala's alarm, but then suppresses it in favor of a higher goal. Courage is therefore not a quiet nerve, but a magnificent internal argument. where the thinking mind chooses to act in the very face of the storm. Nightmares are the brain's way of practicing for frightening events in a safe, simulated environment. We spend a significant portion of our sleep in the vivid, emotional world of rapid eye movement, or REM sleep. This is the stage where most dreaming occurs, including our most frightening and unsettling dreams. One prominent theory, the threat simulation theory, suggests that nightmares serve an important evolutionary function. They are a form of mental rehearsal. The dream state allows the brain to create and experience threatening scenarios, being chased, falling, or being unprepared, without any actual physical risk. By running these simulations, the brain can practice its threat recognition and avoidance skills, essentially fine-tuning its survival responses. The intense emotion of the fear helps to solidify the lesson learned during the simulation. Nightmares, in this light, are the mind's own private training ground, a shadow play of survival, all unfolding in the safety of sleep. The hippocampus is a part of the brain that ties fear to a specific time and place. The amygdala is the simple, powerful alarm, but it does not work alone. It signals that there is danger, but it doesn't record the details of the environment. That task belongs to the hippocampus, the brain's archivist, which builds the rich, detailed tapestries of our memories. The hippocampus is responsible for contextual fear memory. It is the part of the mind that remembers where the bad thing happened, the specific curve in the road, the scent in the air, or the look of the room. This is why returning to a place where you were once frightened can cause the anxiety to rush back, even if you know you are now safe. The hippocampus and amygdala work together, one providing the raw emotion, the other binding it to the world, a powerful partnership designed to create a map of places to avoid. A moderate amount of fear or stress can actually improve performance and focus. This concept, often explored as the Yerkes-Dodson law, suggests that our relationship with arousal is not linear. When we have no stress at all, our performance is often low. We are unmotivated and inattentive. As a small amount of stress, a deadline, a challenge, a mild sense of apprehension is introduced, our performance sharpens dramatically. This is the body's optimal arousal state. The heightened senses and focused mind, gifts of a mild alert response, allow us to function at our peak. However, there is a tipping point. If the fear becomes too great, it transforms from a focusing agent into a debilitating force. Performance then plummets. This delicate balance reveals that a small, well-managed spark of fear is not an enemy, but a powerful, ancient motivator, a tool to bring the mind into sharp, clear relief. Fear can be socially contagious, passed from one person to another without a word. We are deeply social creatures, tuned not just to our own internal states, but to those of the people around us. When we observe someone else in a state of fear, their body language, their facial expressions, or the sound of their voice, our own brain can mirror that state. This is a function of our mirror neuron system, which allows us to feel empathy. Our own amygdala can become active simply by witnessing another's fright, a phenomenon called observational fear learning. This was a critical survival tool for our ancestors. If one member of the group spotted a hidden danger, their silent, visible fear could be instantly transmitted to the entire tribe, alerting them all to a threat they had not yet seen for themselves. It is a shared, collective alarm, a ripple of warning that binds us together. The startle reflex is one of the body's fastest and most fundamental defensive actions. It is a primitive response, managed not by the higher thinking brain, but by the ancient reptilian brainstem. When you are surprised by a sudden, unexpected stimulus, like a loud bang or a sudden touch, your body reacts with incredible speed. You flinch, your eyes blink hard, your shoulders hunch, and your neck muscles tighten, pulling your head down. This entire sequence unfolds in just a fraction of a second, faster than any conscious thought. Its purpose is purely defensive. The eye blink protects our most vulnerable sensory organs. The hunching and tensing of the neck and shoulders is an instinctive attempt to protect the spine and throat from a potential attack. This reflex is a raw, powerful piece of our animal inheritance, a built-in suit of armor that deploys in an instant. The smell of fear is a real phenomenon, as mammals can release chemical signals called pheromones when in distress. While we are highly visual creatures, we are also part of an older chemical world. Many animals, including mammals, communicate using chemosignals or pheromones. When an animal is under intense stress, its body can release specific chemicals in its sweat or other fluids. When another animal of the same species detects these alarm pheromones, it can trigger an alert state in their brain, even without any other sign of danger. Research suggests that humans are also sensitive to these signals. When people smell the sweat collected from others who are in a frightening situation, their own amygdala shows increased activity. It is a subtle, invisible conversation, an ancient, chemical broadcast of anxiety that passes silently from one mind to another, a hidden layer of shared connection. Anxiety is different from fear. Anxiety is the anticipation of a future threat, while fear is the response to a present one. Fear is a sharp, immediate, and visceral reaction. It is the body's response to a clear and present danger right in front of you, the car skidding, the dog barking. It is an instinct designed to solve a problem in the now. Anxiety, its close cousin, is a more complex and lingering emotion. Anxiety is the shadow cast by the future. It is the unease of what if. It is the mind leaving the present moment to scan the horizon for potential problems, replaying past worries and rehearsing future ones. While fear activates the immediate fight or flight system, anxiety creates a lower, longer-lasting state of vigilance and tension. It is the mind's attempt to protect itself not from a present predator, but from the infinite, imagined possibilities of tomorrow. The human brain processes fear along two distinct pathways, one fast and one slow. When a threatening image enters your eye, the information is sent to a central sorting station in the brain, called the thalamus. From there, the signal splits and takes two different roads. The low road is a fast, unpaved shortcut. The signal travels directly from the thalamus to the amygdala, the alarm center. This path is quick and blurry, providing only a rough outline of the danger, but it triggers the immediate, life-saving fight or flight response. At the exact same time, the high road is taken. This signal travels from the thalamus up to the visual cortex, the brain's thinking, logical center. This path is slower and more methodical. The cortex analyzes the signal in detail and makes a final judgment. It is the high road that sends the all-clear message, calming the amygdala when it realizes the snake on the path was just a coiled rope. There is a very rare genetic condition, Urbach-Wiener disease, that can destroy the amygdala and effectively remove the ability to feel fear. There is a famous case of a woman known as patient SM, whose amygdala was hardened and wasted away by this disease. Her life provides a profound and gentle window into what a human being is without this ancient guardian. She has been held at knife point, walked through haunted houses, and shown venomous spiders and snakes. yet she reports feeling no fright, only curiosity or mild interest. But her lack of fear comes at a cost. She has trouble recognizing fearful expressions in others, struggles to judge the trustworthiness of strangers, and has repeatedly found herself in dangerous situations. Her story is a quiet lesson, teaching us that fear is not a weakness or a flaw. It is a fundamental protective sense, a silent companion that helps us navigate the complexities and dangers of the world, a teacher we do not always enjoy, but desperately need. The gut-brain axis plays a profound role in regulating feelings of fear and anxiety. We often speak of a gut-wrenching feeling, or having butterflies in the stomach when we are nervous. These are not just metaphors. They are descriptions of a deep biological connection. The gut and the brain are in constant, two-way communication through a vast network of nerves and chemical signals. In fact, the gut contains so many neurons that it is often called the second brain. It also produces a large amount of the body's neurotransmitters, including serotonin, which is crucial for regulating mood. An imbalance in the healthy bacteria that live in our gut can send signals of distress to the brain, increasing feelings of anxiety. This intimate, flowing conversation means that our emotional state is deeply intertwined with our physical digestion, a holistic system where unease in one place is felt deeply in the other. The sound of a human scream is uniquely engineered to hijack our brain's attention. A scream is not just a loud noise, it has a special acoustic property that sets it apart from all other sounds in our environment. This property is called roughness. Roughness refers to how quickly a sound changes in volume, and a human scream fluctuates with extreme, rapid intensity. Normal, calm speech does not have this quality. Researchers have found that this roughness directly activates the brain's fear circuit, the amygdala, bypassing the normal hearing and processing centers. A scream is an auditory alarm that is biologically impossible to ignore. It is a pure sonic expression of terror, designed by evolution to cut through every other distraction and signal to every human within earshot that a life is in immediate, profound danger. It is the sound of survival itself. The fear of the unknown is one of the most fundamental anxieties we experience. Our brains are, above all, prediction machines. They spend every moment of our lives trying to build a stable, coherent model of the world, allowing us to anticipate what will happen next. This ability to predict gives us a sense of control and safety. The unknown shatters this uncertainty, ambiguity, and novelty are deeply unsettling because they rob the brain of its ability to forecast the future. The mind is left in a state of high alert, unable to determine if a situation is safe or dangerous. It often defaults to assuming the worst, just in case. This is why we may fear a dark room, a new job, or a future we cannot see. It is not a fear of a specific thing, but a fear of not knowing, an ancient discomfort with the void that lies just beyond the edges of our understanding. Trypophobia, a fear or revulsion of patterns of small holes, may be an ancient survival instinct. For some people, the sight of a honeycomb, a lotus seed pod, or even the bubbles in a cup of coffee can trigger a powerful, visceral reaction of disgust and fear. This seems, at first, to be a deeply irrational response, but researchers have suggested it may be another evolutionary echo, a misfiring of an ancient, non-conscious warning system. Many of the world's most dangerous animals, such as venomous snakes, octopuses, and insects, have skin patterns that feature high contrast, repetitive, hole-like shapes. Furthermore, Many infectious diseases, like smallpox or measles, manifest as rashes and pustules on the skin. It is possible that this intense discomfort is the brain's overzealous ancient defense mechanism, a powerful avoid signal that has mistakenly attached itself to harmless objects in the modern world. Our posture and body language can send fear signals back to our own brain. We tend to believe that emotions flow in one direction. We feel fear, and then our body reacts by tensing up. But the connection is a two-way street, a concept known as embodied cognition. The brain is constantly monitoring the body's position to understand its own emotional state. If you sit in a hunched, defensive, or closed-off posture, your body is sending a message of vulnerability or threat to your brain. This can, in turn, make you feel more anxious and fearful, even if there is no external reason. Conversely, adopting an open, upright, and powerful posture can send a signal of confidence and safety back to the mind, subtly lowering feelings of stress. It is a quiet feedback loop, where the body's simple shape can gently whisper to the mind, influencing the world it feels within. Some fears can be inherited from our parents, without ever having a bad experience ourselves. We often assume that our phobias are the result of our own traumas or lessons, but science is revealing a much deeper, more mysterious form of inheritance. This is the realm of epigenetics. When a parent has a profoundly frightening experience, it can sometimes leave a chemical mark on their genes. This epigenetic tag doesn't change the DNA itself, but it can change how that DNA is read, particularly in genes related to stress response. This tag can then, in some cases, be passed down to their children. The child may then be born with a heightened sensitivity, a preparedness to fear a specific thing, such as a particular smell, that they have never encountered before. It is a quiet, ghostly inheritance, a memory of a fear that is older than the life it lives in, a story of survival written in invisible ink. The uncanny feeling of being watched is a real cognitive effect. You are sitting in a room, perhaps reading a book, and you get a sudden, prickling sensation on the back of your neck. You feel, with certainty, that someone is staring at you. You look up, and you are right. This is not a supernatural power, but a function of the brain's gaze detection system. This vast neural network is dedicated to one task: processing where other people are looking. It is extremely sensitive, capable of picking up on the most subtle cues, even in our peripheral vision. We can often register the geometry of another person's head and eyes turning toward us without consciously seeing it. The brain flags this as important, and the resulting sense of unease is the alarm bell that makes us look up. It is a primal social survival skill, a silent awareness of the attention of others. We are biologically primed to fear things that move in unnatural or non-biological ways. Our brains have a deep, innate understanding of how living things are supposed to move. We are experts in biological motion, the smooth, flowing, and predictable ways that arms, legs, and bodies bend and sway. When something breaks these rules, it sets off an immediate alarm. This is why a spider's skittering, multi-jointed walk is so unsettling, or why the jerky, halting movements of a broken doll in a horror film are so frightening. These motions are wrong. They defy the brain's predictions of life, signaling something that is broken, diseased, or perhaps a new kind of predator that our internal rulebook does not understand. This fear is a deep, aesthetic revulsion, the mind recoiling from a pattern that does not belong to the living world it knows. Plants can sense danger and send out warnings to their neighbors. A plant does not have a brain or a nervous system, so it cannot feel fear as we do, but it is deeply aware of its own survival. When a plant is attacked, for instance by a caterpillar chewing on its leaves, it is not a passive victim. The damaged cells release a complex bouquet of volatile organic compounds, which are essentially chemical signals released into the air. This chemical message is a warning. Other nearby plants can smell this signal and begin to mount their own defenses before the attacker even arrives. They might start producing bitter toxins in their own leaves to make themselves taste bad, or release chemicals that attract the predator's predators, such as parasitic wasps. It is a silent, invisible, and deeply intelligent conversation, a kingdom of green sending its alarms on the wind. The jump scare in a film works by exploiting our brain's simple threat detection mechanisms. It is one of the oldest and most effective tools for creating fear, and its power lies in its simplicity. A jump scare is not about complex psychological terror. It is a direct physical assault on the nervous system. It relies on two key elements: a long period of quiet, which allows our guard to drop, followed by a sudden, loud noise and an abrupt, threatening visual. This combination is the perfect recipe to trigger the amygdala's low-road panic response. The brain doesn't have time to use the slow, logical high road to assess the threat. It just reacts. The loud, non-linear sound mimics an animal's cry, and the sudden visual triggers the startle reflex. It is a pure, primal manipulation, a button that, when pushed correctly, guarantees a jolt of physiological fear. Exposure therapy, the most effective treatment for phobias, works by patiently retraining the brain. If a phobia is a powerful, learned association between a harmless object and a feeling of terror, then exposure therapy is the process of gently unlearning it. It is based on the principle of fear extinction, which we have touched on. Under the guidance of a professional, a person is gradually and repeatedly exposed to the thing they fear, but in a completely safe and controlled environment. It starts small, perhaps just looking at a picture, and slowly builds over time. With each safe exposure, the brain's prefrontal cortex is given a chance to write a new memory. It learns, "I have seen this and I am safe." Over time, this new calm memory becomes stronger and more dominant, allowing the logical mind to quiet the amygdala's old, outdated alarm. It is a slow, courageous process of teaching the mind a new, more peaceful truth. We often imagine that a racing heart is a symptom of fear, but our brain also interprets it as a cause. The connection between our mind and body is a continuous loop. This was the core of the James Lang theory of emotion. It proposed that we do not run from a bear because we are afraid. Instead, we become afraid because we are running. The theory suggests that the emotion is the brain's interpretation of its own physiological state. When the brain senses the body's fight or flight response, the heart pounding, the palms sweating, the muscles tensing, it searches for a reason. It labels this constellation of bodily feelings as fear. This means that our physical state can profoundly influence our emotional one. If your heart is racing from caffeine, your brain might be more likely to interpret a neutral situation as frightening. It is a constant, subtle dance, where the body's rhythm helps to compose the mind's music. The posture of fear in animals, such as a cat arching its back, is a complex signal of both fear and aggression. This is not a simple gesture of surrender. It is a defensive threat display, a behavior born from a place of deep fear, but designed to project a warning. When a cat is cornered and terrified, it will arch its back, its fur will stand on end, piloerection, and it will hiss, baring its teeth. This display is a desperate gamble. The cat is using every tool it has to make itself look larger, more dangerous, and more intimidating than it feels. It is simultaneously a plea not to be attacked and a promise that an attack will be met with a ferocious fight. This posture is a painful negotiation, an animal trapped between its terror and its will to survive, a living sculpture of defensive desperation. Fear can significantly narrow our focus of attention, a phenomenon known as attentional tunneling. When we are calm, our attention is like a broad lantern, illuminating a wide field of view and allowing us to take in the rich context of our surroundings. When a threat is detected, the amygdala's alarm forces this lantern to become a laser. Our focus narrows intensely onto the source of the perceived danger, ignoring almost everything else. This is a powerful survival mechanism, ensuring all our cognitive resources are aimed at the one thing that matters most. However, this tunneling can also be a liability. It is why, in a moment of panic, a person may not see an obvious escape route to their left or right. Their world is shrunk to the threat and nothing else. A stark, focused reality sculpted by the urgency of fear. The feeling of fear can be passed down through generations in some animals, even without any direct contact. In experiments, researchers have trained mice to fear a specific, harmless smell, like that of cherry blossoms, by pairing it with a mild, unpleasant sensation. They found that the offspring of these mice, and even their grandchildren, would show a strong fear reaction to the smell of cherry blossoms, despite having never encountered it before. This is another example of epigenetic inheritance. The original learned fear appeared to have left a chemical signature on the parent's DNA, which was then passed down. This inherited memory prepares the new generation for a danger that its ancestors learned to avoid, a form of biological wisdom, a cautionary tale told not in words, but in the quiet language of the genes themselves. Our pupils dilate when we are afraid, and this serves two distinct purposes. The most well-known reason is to improve vision. When the fight or flight response is triggered, the nervous system causes the pupils to widen, a process called mydriasis. This allows more light to enter the eye, which can sharpen vision in low light conditions and make it easier to spot threats in the shadows. But there is a second, more social function. Just as we use the whites of our eyes to communicate, dilated pupils are a powerful, silent signal to others. When we see someone with wide, dark pupils, our brain non-consciously interprets it as a sign of high alert or emotional arousal. This can, in turn, trigger our own amygdala, making us more vigilant. It is another layer of our shared, unspoken language of survival, a signal of alarm broadcast from the very center of the eye. The fear of public speaking is the single most common phobia, often ranking higher than the fear of death. This fear, known as glossophobia, feels irrational to many who experience it. Why should standing in front of a group of colleagues be more terrifying than the end of existence? The answer lies in our deep evolutionary past and the fear of social rejection. For our ancestors, being positively regarded by the tribe was essential for survival. To stand before the group, fully exposed, and to be judged by them, taps into a primal fear of ostracism. A poor performance feels, to the ancient brain, like a threat of being cast out. The pounding heart and shaking hands are the body's response to what it perceives as a high-stakes social survival test. It is not a fear of speaking, but a deep, visceral fear of being found unworthy by the very people we depend on. The startle to threat response can be measured with incredible precision using an eye blink. This is a foundational tool in fear research, known as the fear potentiated startle. A person's natural reflexive eye blink is measured when they hear a sudden, loud burst of noise. Then, this test is repeated while the person is looking at something that makes them anxious or afraid. Researchers consistently find that the person's startle blink is significantly more forceful and pronounced when they are already in a state of fear. The brain's fear system, already on alert, amplifies the separate, simple startle reflex. This provides scientists with a pure, objective, and physiological measurement of a person's underlying fear level, a way to quantify the mind's vigilance by observing the simple, rapid movement of an eyelid. The sensation of your blood running cold is a real physiological event. In a moment of extreme terror, the body prepares for the possibility of a physical wound. The fight or flight response initiates a process called peripheral vasoconstriction. The nervous system instructs the tiny blood vessels, the capillaries, near the surface of the skin to clamp down and narrow. This has two immediate effects. First, it shunts the blood away from the skin and deeper into the core of the body, where it can supply the large muscles and vital organs. Second, it reduces the amount of blood you would lose from a cut or gash on your arms or legs. This internal redirection of the body's warm, flowing rivers of blood is what creates the pale, clammy complexion associated with fright, and the sudden, chilling sensation that gives this ancient feeling its name. The Broca's area in the brain, our primary center for speech production, can become inhibited during intense fear. This is the neurological basis for being speechless with terror. When the amygdala sounds its most powerful alarm, it can disrupt the function of other, less essential brain regions. The prefrontal cortex, which manages complex thought, and Broca's area, which forms coherent sentences, can be partially taken offline. Survival takes priority over conversation. This is why, in a moment of panic, a person might find they can only stammer, shout a single word, or make no sound at all. The body's need for a primal scream, a sound generated by the more primitive limbic system, overrides the brain's sophisticated machinery for language. The intricate, delicate mechanism of speech simply yields to the raw, overwhelming urgency of the alarm. Xenophobia, the fear of strangers or foreigners, is a learned fear that exploits our brain's natural in-group preference. Humans are not born with this fear, but we are born with a powerful instinct to categorize our world, and this applies especially to people. Our brains rapidly sort individuals into us and them, our family, our tribe, our group. This was once a useful survival shortcut. In our ancestral past, a stranger could represent a significant threat, competing for resources or bringing conflict. This ancient tendency, however, can be manipulated. Fear-based narratives and propaganda can teach the brain to associate an outgroup with danger, activating the amygdala and creating a sense of threat where none objectively exists. It is the hijacking of an old protective instinct, twisting the simple comfort of us into a manufactured, learned fear of them. We can be startled by our own reflection because our brain processes the image as a stranger before it identifies it as us. This brief moment of fear is a fascinating glimpse into the speed of our brain's processing. When you catch a sudden movement in a mirror out of the corner of your eye, the first responder system is the low road to the amygdala. This fast, primitive pathway only sees the basic outlines, a human-like shape, moving unexpectedly. It instantly flags this as a potential threat, an intruder. Your body tenses and your heart jumps. Only a fraction of a second later does the high road kick in. The slower, more sophisticated visual cortex processes the image in detail, recognizes your own features, and sends the all-clear signal to the amygdala, calming the alarm. For one split second, your own ancient guardian has seen you as a stranger in your own home. The fear of heights, acrophobia, may be linked to an over-reliance on our sense of vision. Our sense of balance is a complex dance between three systems: our inner ear, which senses rotation and gravity; our proprioception, the sense of our body in space; and our vision, which gives us a horizon. For most people, these systems work in harmony. For someone with acrophobia, it is suggested that they may overdepend on their visual cues. When they are high up, the ground is too far away to be a stable visual reference, and the horizon can feel unreliable. This visual uncertainty creates a sensory conflict. The brain receives mismatched signals from the eyes and the inner ear, leading to disorientation and a powerful, visceral feeling of instability. The fear is not just of falling, but a deep, sickening anxiety that their very sense of balance has been compromised. We often check for threats in a scanning pattern that prioritizes the horizontal plane. When we enter a new, unfamiliar room, our eyes do not just dart around randomly. They tend to perform a rapid side-to-side sweep, prioritizing the horizon. This is an ancient, programmed behavior. For most of our evolutionary history, the most immediate dangers, predators or rivals, would appear on the ground and approach from the left or right. We are not as instinctively programmed to check above us, such as in trees or far below us. This horizontal scanning is a fast, efficient way to assess the most likely avenues of threat. It is a quiet, automatic behavior, the mind's old patrol route, ensuring the coast is clear before we allow ourselves to settle. A habit carved into our senses by the shape of the ancient, flat savannas we once called home. The fear of needles, or trypanophobia, is often linked to an unusual, inherited reflex. For most phobias, the body's reaction is the classic fight or flight response. The heart rate and blood pressure increase. But for a significant number of people with a fear of needles or blood, the opposite happens. They experience a vasovagal syncope. When they see the needle, their amygdala alarms, but the body's response is different. After an initial spike, their heart rate and blood pressure suddenly drop. This dramatically reduces blood flow to the brain, leading to dizziness, a graying of vision, and fainting. This reflex, which seems so counterproductive, may be an ancient evolutionary strategy. By playing dead or fainting, an ancestor might have been non-threatening to a predator. Today, this reflex misfires, transforming a simple medical procedure into a profound physiological event. The emotion of awe is often described as a mixture of fear and wonder. When we stand before something vast and overwhelming, the edge of the Grand Canyon, the immense, silent power of the ocean, or the night sky filled with stars, the feeling is not simple. It is a profound, shivery experience. This is awe. It is a respectful, almost reverent fear. It triggers a sense of our own smallness, a feeling that we are in the presence of something much larger and more powerful than ourselves. This feeling, unlike a direct threat, does not trigger a desire to flee. Instead, it seems to quiet the mind's internal chatter, making us feel more connected to the world at large. Awe is the fear that does not shrink our world, but dramatically and beautifully expands it. A moment of terror and peace intertwined. A fear hierarchy is a tool used in therapy to gradually map and dismantle a phobia. When a person is working to overcome a deep-seated fear, they cannot simply confront the most terrifying version of it. The brain's alarm would be too overwhelming. Instead, a therapist helps them build a gentle ladder. This is the fear hierarchy. They work together to list all the related triggers, from the least scary to the absolute most. For a fear of dogs, the bottom rung might be looking at a cartoon of a dog. A middle rung might be watching a dog play from across a park. The very top rung would be petting a large, unfamiliar dog. By starting at the bottom and mastering each small step, the person slowly and patiently builds a new library of safe memories. It is a careful, courageous ascent, dismantling the fear one small, manageable piece at a time. The absence of fear can lead to a failure in avoidance learning. We learn not only from our mistakes, but from our near misses. When you almost touch a hot stove, the small jolt of fear you feel is a powerful teacher. It ensures you will be more careful next time. This is avoidance learning. People who have damage to their amygdala, and therefore a reduced capacity for fear, struggle with this. They can learn that a choice is bad, but they often fail to feel the anticipatory anxiety that stops the rest of us from repeating a mistake. They might, for example, repeatedly return to a gamble that they know is risky because they do not feel the uh-oh sensation, the gut-level warning, as they approach it. This shows that fear is not just a response. It is a critical guide, a quiet voice that uses past shadows to help us navigate the choices of the present. The Moro reflex in infants, their innate fear of loud noises or falling, serves a critical social purpose. When a baby is startled, it does not just freeze. The reflex is a dramatic two-part motion. First, the baby flings its arms and legs wide, its back arching, as if to make itself as large as possible. This is immediately followed by the second phase, where the arms and legs are pulled in tightly to the chest, and the baby begins to cry. While the first motion is a pure startle, the second phase is a brilliant evolved signal. The entire reflex is a non-verbal, desperate, and unmistakable command. I am in danger, grab me, hold me. It is an instinct that transforms a moment of individual fear into an immediate social plea for protection, a powerful built-in tool to ensure a parent's and caregiver's instant protective response. Fear of snakes, or ophidiophobia, is so common that our brains have a fast track for detecting them. In experiments, researchers have shown people a screen filled with many different, non-threatening images, like flowers or leaves. Hidden among them is a single image of a snake. Even when the images are flashed so quickly that a person cannot consciously identify them, their brain is able to detect the snake. This suggests we have a snake detection template, an evolved part of our visual system that is specifically tuned to the coiling S shape of a serpent. Like the fear of spiders, this is an ancient preparedness. For millions of years, a rapid, pre-conscious ability to spot a snake was a profound survival advantage. This ancient, watchful part of our mind still scans the world for that one particular, dangerous pattern. The human voice becomes higher pitched when a person is afraid. This is a direct physical consequence of the body's fight or flight response. When the alarm is sounded, the muscles throughout the body tense up, and this includes the delicate, tiny muscles of the larynx or the voice box. The vocal cords are stretched taut, like the string of a guitar being tightened. When air from the lungs passes over these tightened cords, the sound they produce is higher in frequency. This change is almost impossible to control. It serves as an immediate, involuntary, and universally understood signal of distress. Long before we have time to process the words someone is saying, the high, strained pitch of their voice alone communicates a clear, ancient message of fear, alerting everyone nearby that something is wrong. The vagus nerve is a primary communication highway that reports fear from the body back to the brain. This long, wandering nerve, its name meaning wanderer in Latin, is a physical link in the gut-brain axis. It snakes down from the brainstem, touching the heart, the lungs, and nearly all the major organs of the digestive tract. It is a vast sensory network, and one of its main jobs is to listen. It constantly sends reports back to the brain about the body's internal state. When you feel that gut-wrenching lurch of fear, it is the vagus nerve detecting the sudden halt in digestion and the change in your stomach, and then sending a powerful something is wrong signal up to the amygdala. This deep bodily feeling is not just a reaction to the fear. It is an active ingredient in the fear, a message from your core confirming the mind's alarm. The cocktail party effect describes our brain's ability to filter out noise, but a sound of fear will instantly break through. Imagine you are in a crowded, noisy room, deep in conversation. Your brain is performing a remarkable feat. It is actively suppressing all the other voices and sounds, allowing you to focus on just one. This is the cocktail party effect. But this filter is not absolute. It has a built-in breakthrough clause for anything that signals danger. If someone across the room suddenly shouts in a high-pitched, fearful tone, or even just speaks your own name, your attention will be captured instantly. Your brain's sentinel, the amygdala, is always listening in the background, scanning the unattended noise for specific, high-priority, survival-relevant cues. It is a layer of protection that never sleeps, even when your conscious mind is focused elsewhere. The emotional Stroop test reveals how fear can hijack our basic cognitive processes. In the classic Stroop test, a person is shown a word like blue, written in red ink, and is asked to name the color of the ink. This is difficult because our brain's automatic reading process interferes with our ability to name the color. The emotional version of this test uses words that are threatening, such as danger or fear, mixed with neutral words like chair or table. All the words are printed in neutral colors. Researchers find that people with anxiety take significantly longer to name the colors of the threatening words. Their brain's attention becomes stuck on the fearful meaning of the word, even when they are trying to ignore it. This simple test provides a window into how the amygdala's alarm can reach out and interfere with even the simplest tasks, pulling the mind's resources toward the perceived threat. The fear of holes, or trypophobia, is more accurately classified as disgust rather than fear. While we often group it with phobias, the emotional and physical reaction is subtly different. A typical fear response, like seeing a snake, primes the body for fight or flight. The heart races and the senses sharpen. But for people who experience trypophobia, the reaction is one of profound revulsion. Instead of a desire to run, there is a feeling of nausea, a skin-crawling sensation, and a deep urge to destroy the offensive pattern. This links the feeling less to the amygdala's fear circuit and more to the insula, a part of the brain that processes disgust and monitors the body for contamination. As we've seen, this is likely an overactive defense mechanism, a part of the mind's behavioral immune system that is trying to protect the body from patterns it associates with parasites, infection, and decay. We are more likely to have nightmares during the later half of the night, as our REM sleep cycles grow longer. Sleep is not a single monolithic state. It unfolds in cycles of about 90 minutes, each containing different stages. The deep, restorative, slow-wave sleep is dominant in the first half of the night, but as the night progresses toward morning, the proportions shift. We spend more and more time in rapid eye movement, or REM sleep, the stage of vivid emotional dreaming. Because our REM periods become longer and more intense in the hours just before we wake, this is the prime territory for nightmares. A nightmare is, in essence, a REM dream that has become overwhelmed by the brain's fear circuitry. This timing means our most frightening internal simulations are often staged just before the dawn, in the mind's deepest and most active theatre. The looming effect describes how our brain perceives approaching objects as more threatening than retreating ones. Our minds are not neutral observers of motion. We have a powerful built-in bias. An object that is getting bigger in our visual field, that is, looming, is processed as an urgent priority. Our brain automatically calculates that this object is on a collision course with us, and it dedicates far more neural resources to tracking it than it would to an object moving away. This is why a car driving toward you feels more immediate and demanding of your attention than one driving away, even if both are moving at the same speed. This looming bias is a fundamental survival tool, a predictive, time-saving calculation that ensures we react to approaching threats before they arrive, not as they are arriving. It is the mind's way of anticipating danger in motion. Sleep paralysis is a state where the brain's fear centers are active, but the body is still in its sleep-induced paralysis. During REM sleep, the brainstem sends out signals that effectively paralyze the body's voluntary muscles. This is a crucial safety feature, preventing us from physically acting out our vivid dreams. Sleep paralysis occurs during the messy transition between sleep and waking. The conscious mind wakes up, but the body's paralysis, the atonia of REM sleep, has not yet faded. The result is a profoundly terrifying state. You are awake, aware, but cannot move. To make matters worse, the amygdala, which is highly active during REM sleep, often remains active. This combination, a feeling of immobility and a brain already primed for fear, is what conjures the terrifying hallucinations that often accompany the state, a waking nightmare born from the mind's half-awake confusion. The olfactory limbic connection means that fear-related therapies sometimes use smell to help process trauma. Because the sense of smell has a direct primitive pathway to the amygdala and hippocampus, it is a powerful key that can unlock deeply buried emotional memories. This connection, which can be so unsettling, is also being explored as a tool for healing. In some therapeutic settings, a safe and calming scent, such as lavender, may be paired with the difficult work of revisiting a traumatic memory. The goal is to build a new association. By repeatedly linking the calming scent to the memory, the brain can begin to lay down a new, competing safety track. The scent acts as an anchor, a non-verbal signal that helps the prefrontal cortex regulate the amygdala's alarm, slowly helping to disconnect the memory from its overwhelming physical feeling of fear. Fear can be a driving force behind confirmation bias. This is the mind's tendency to seek out, interpret, and favor information that confirms what it already believes. When we are afraid of something, this bias goes into overdrive. The fear primes the brain to look for evidence that justifies its own anxiety. If you are anxious about flying, you will not notice the thousands of planes that land safely. your attention will be magnetically drawn to the one news story about a minor incident. This is the brain's attempt to validate its own warning signals. The fear wants a reason, so it actively filters the world, seeking out the fragments of evidence that prove the danger is real. It is a self-perpetuating cycle, where the fear itself builds the very walls of the reality it wishes to prove. The startle response is so fundamental that it can be observed in a fetus still in the womb. As early as the second trimester, the developing nervous system is already wiring its most basic protective reflexes. If a sudden, loud sound is made near the mother's abdomen, ultrasound can capture the fetus reacting with a classic startle. It will jolt, its limbs may extend, and its heart rate will quicken. This is the Moro reflex, our innate fear of loud noises, already present and functional long before birth. It is a profound testament to the ancient, non-negotiable importance of our survival instincts. Before the brain has ever formed a conscious thought or a memory, it is already practicing its first and most essential duty: to recognize a potential disturbance and react in an instant. The periaqueductal gray, or PAG, is a region in the brainstem that acts as the final command center for our fear responses. When the amygdala sounds the initial alarm, it sends its signal to this crucial ancient structure. The PAG is the part of the brain that ultimately decides what to do with the fear signal. It is the master switch that selects the most appropriate survival program. Based on the proximity and nature of the threat, it is the PAG that will initiate the freeze response, allowing for assessment. If the threat comes closer, it is the PAG that flips the switch to the fight or flight response, flooding the body with adrenaline. And if the threat is overwhelming and escape is impossible, this same region can trigger a state of shutdown or collapse. It is the brain's tactical officer, choosing the body's defensive strategy in a fraction of a second. A fear avoidance cycle is what entrenches a phobia and makes it grow stronger over time. The cycle begins with a fear. When a person avoids the thing they are afraid of, such as taking the stairs instead of the elevator, their brain experiences an immediate, profound sense of relief. This relief is a powerful reward. The brain's reward system, the nucleus accumbens, essentially tells the amygdala, "See, we avoided the danger, and we were rewarded with safety." This reinforces the original fear. It teaches the brain that the avoidance behavior was the correct response. With each successful avoidance, the phobia is strengthened, and the person's world becomes a little bit smaller. The avoidance itself, which feels like a solution, becomes the very mechanism that feeds and nurtures the fear, trapping the mind in a loop of its own making. The negative priority effect means our brains process threatening faces faster than happy or neutral ones. Our minds are not democratic in how they process social information. They are biased towards survival. In Find the Face in the Crowd experiments, a single angry or fearful face will pop out of a crowd of happy or neutral faces much more quickly. A happy face in a crowd of angry ones, however, does not get the same priority. Our visual system is specifically tuned to rapidly detect potential social threats. An angry face represents a direct personal danger, while a fearful face signals a danger in the environment. Both are treated as high-priority information that must be analyzed immediately. This slight, fractional second advantage in processing time is an echo of a time when quickly identifying a rival or an alarm bearer was a matter of life and death. The Tale of Two Fears describes how the brain processes innate versus learned threats. Our brains handle fear in different ways, depending on how we acquired it. An innate fear, like the primal fear of a snake, is processed through a very short, fast, and primitive circuit in the amygdala. It is a hardwired, inflexible response. A learned fear, however, like the fear of a specific neutral sound that you've learned to associate with a bad experience, is more complex. This fear is processed through a more sophisticated circuit that involves not just the amygdala, but also the hippocampus and the prefrontal cortex. This learned fear pathway is more plastic, more adaptable. This distinction is why it is often easier to unlearn a specific personal phobia than it would be to extinguish a deep, primal fear. The brain has built different roads for its ancient wisdom and its personal experiences. The freezing response to fear is accompanied by a unique physiological state of high alert and low movement. It is not a passive pause, but an intensely active preparatory state. When an animal freezes, it is not relaxed. On the outside, it is perfectly still. But on the inside, its nervous system is in a state of co-activation. Both the go system, the fight or flight, sympathetic nervous system, and the stop system, the rest and digest parasympathetic nervous system, are turned on at the same time. This is like holding down the accelerator and the brake of a car simultaneously. The heart rate slows down, the brake, making the animal quiet, but the muscle tone is high and ready, the accelerator. This creates a state of incredible silent readiness, allowing the animal to gather information while being primed to explode into action at the first possible moment. The Toxoplasma gondii parasite is a famous example of fear circuitry being chemically hijacked. This microscopic parasite has a complex life cycle. It must get from its intermediate host, a rodent, into its final host, a cat. To achieve this, it has evolved a truly remarkable strategy. When it infects a mouse or a rat, the parasite forms cysts within the rodent's brain, and it specifically targets the amygdala. It then chemically alters the brain's fear response. The rodent's general anxiety levels remain, but its specific, innate, and life-saving fear of the smell of cat urine is turned off. In fact, it is often replaced by a strange, fatal attraction. The parasite doesn't just remove the fear, it rewires the circuitry, luring the rodent toward the one predator it must avoid. A stunning example of one creature's survival mechanism overriding another's. The fear of the other has a counterpart in neophilia, the love of the new, while the fear of the unknown, or neophobia, is a powerful drive to keep us safe. We also possess an equally important, competing drive. Curiosity, this is neophilia. Our survival as a species has depended not just on avoiding danger, but also on seeking out new resources, new food sources, new territories, and new allies. These two systems, neophobia and neophilia, exist in a constant, delicate balance. Some individuals are naturally more cautious, preferring the familiar. Others are more exploratory, driven to investigate the unknown. The health of a species relies on having both: the brave explorers who find the new, and the cautious guardians who protect the known. It is a perfect ancient tension between the shadow and the light. When we are afraid, our blood actually becomes stickier and more prone to clotting. This is another one of the body's hidden and profound preparations for a physical confrontation. The fight or flight response is not just about muscles and oxygen. The same hormonal cascade that readies the body for action also signals to the blood itself. The body increases the production of platelets, the tiny cell-like fragments that are responsible for clotting. It also releases other coagulant, proteins into the A bloodstream. The entire system is being primed for injury. If a wound were to occur, this pre-preparation ensures that a clot will form much more quickly and robustly, minimizing blood loss. It is a microscopic, internal form of defense, the body readying its own repair crew long before any damage has been done. The feeling of dread is a distinct form of fear, characterized by its focus on an inevitable outcome. Standard fear is about a possible threat. It is a burst of energy designed to help you prevent a bad thing from happening. Dread is different. Dread is the heavy, sinking, and sickening feeling that arises when the bad thing is no longer a possibility, but a certainty. It is the feeling of waiting for a storm that is already on the horizon, or anticipating a painful confrontation that you know cannot be avoided. The body is in a state of high alert, but there is no flight or fight option available. This leaves the mind in a painful, anticipatory limbo, a state of anxious helplessness as it waits for the unavoidable to arrive. It is the fear of what is already in motion. Horror and terror, while often used interchangeably, describe two different shades of fear. Terror, in classic Gothic literature, is the fear of anticipation. It is the awful, sickening feeling of suspense, the dread of what might happen. It is the sound on the stairs, the shadow in the corner, the creaking of the door. The mind is stretched, imagining a horror that is yet to be seen. Horror, on the other hand, is the shock and revulsion that comes after the event, when the terrible thing has been revealed. It is the fulfillment of the terror. Terror is the mind racing, and horror is the mind recoiling. One is the fear of the unseen, and the other is the disgust at what has been seen. One is the stretched string, and the other is the sickening snap. The Kuleshov effect in filmmaking demonstrates how our brain manufactures fear based on context. This is a powerful cinematic discovery, named after the Soviet filmmaker Lev Kuleshov. He conducted a simple experiment. He showed an audience an image of a man's neutral, expressionless face. He then showed them an image of a bowl of soup. When asked, the audience said the man looked hungry. He then showed the same neutral face, followed by an image of a child in a coffin. The audience now said the man looked sad and grieving. Finally, he showed the same face, followed by an image of a woman on a divan. The audience perceived the man as looking lustful. In all cases, the face was identical. This effect proves that we project our own emotions and narratives onto what we see. When we watch a horror film, a neutral shot of a dark hallway becomes frightening because the music and the previous scene have told our brains to interpret it as a place of fear. The thalamic theory of emotion first proposed that the body's fear response and the mind's feeling of fear happen at the same time. For a long time, the debate was whether we run because we are afraid, or are afraid because we run. The Cannon-Barth theory, an evolution of this idea, offered a powerful alternative. It suggested that when our senses detect a major threat, the signal goes to a brain region called the thalamus. The thalamus then acts like a splitter, sending the alarm along two pathways simultaneously. One signal goes down to the body, triggering the physical fight or flight response, the racing heart, the tensed muscles. At the very same moment, the thalamus sends a signal up to the brain's cortex, which creates the conscious, subjective feeling of being afraid. In this model, the body's cry of alarm and the mind's understanding of it are two parallel, simultaneous events, born from the same initial spark. The facial feedback hypothesis suggests that just smiling can make you feel happier, and frowning can make you feel sadder. This is a fascinating extension of the body-mind feedback loop. The theory proposes that our facial expressions are not just a result of an emotion, but can also be a cause. The brain, in its constant quest to understand its own state, monitors the 42 tiny muscles in the face. If it detects the physical pattern of a smile, it interprets this as a signal of safety and pleasure, and can subtly lift your mood. Similarly, if you furrow your brow and tense your jaw, the brain reads this as a signal of stress or displeasure, and it can amplify feelings of anxiety or fear. This does not mean we can cure deep-seated fear by simply smiling, but it does suggest a gentle, two-way conversation, where the simple, physical shape of our face can whisper back to the mind, helping to color the world it perceives. The fear of being buried alive, taphophobia, was so widespread in the 18th and 19th centuries that safety coffins were invented. This deep, primal fear of waking up in the dark, silent earth, trapped and helpless, resonated powerfully in an era before modern medicine. The line between a deep coma and death was sometimes tragically blurred. This collective anxiety became so profound that it sparked an entire industry of innovation. These safety coffins were patented with elaborate systems designed to offer a last, desperate hope. Some had a bell on the surface with a cord that was placed in the hand of the deceased. Others included a small air tube to the outside, or a viewing window. Though there is no verified case of one ever being successfully used, their existence is a poignant physical testament to a time when one of humanity's greatest fears felt chillingly mechanically possible. The amygdala hijack is a term for when our emotional, primitive brain completely overwhelms our rational, thinking brain. This is the moment when the low road of fear, the fast and simple path, not only wins the race, but shuts down the high road entirely. It is a state of temporary cognitive blindness. When the amygdala perceives a threat as sufficiently overwhelming, its alarm is so loud that it effectively severs its connection to the prefrontal cortex, the seat of logic, planning, and self-control. This is why, in a moment of pure rage or blind panic, a person may act in ways that are completely irrational and self-destructive. They are, for that moment, being piloted entirely by their most ancient, reactive survival instincts. The thinking, logical self is no longer in command. It has been hijacked by the raw, overwhelming power of the alarm. Our brains are not designed to be in a constant state of low-grade fear, leading to the modern problem of chronic stress. The fight-or-flight system is a masterpiece of evolutionary engineering. It is designed to be a short, intense, and powerful burst of energy, allowing us to survive an acute physical threat. Once the threat is gone, the system is designed to return to a state of calm. But the modern world has introduced a new kind of threat: the psychological, low-grade, and persistent worry. The deadline, the traffic, the financial concern, the endless stream of bad news. The amygdala interprets these abstract worries as threats, and it keeps the body in a state of low alert. The adrenal glands keep trickling out cortisol. This chronic activation, this alarm that never turns off, is what we call chronic stress. It is the misuse of an ancient, brilliant survival tool, applying a sprint or fight response to a marathon of modern anxiety. The tend and befriend response is an alternative to fight or flight, seen more commonly in females. For a long time, the fight or flight model was seen as the universal human response to threat. However, this model was based largely on studies of males. Later research uncovered a second powerful pattern. This is the tend and befriend response. When faced with stress, this instinct drives a person to tend to their offspring, protecting them from harm, and to befriend other members of their social group, creating a stronger, more resilient network. This is driven by a different hormonal cocktail, primarily the hormone oxytocin, which promotes bonding and trust. It is a brilliant evolutionary counter-strategy. While fight or flight is about individual survival, tend and befriend is about the survival of the group, a reminder that in the face of fear, one of our greatest strengths is to quietly and bravely pull together. The fear of blood, or hemophobia, is another phobia that often causes the unique fainting response. Like the fear of needles, this is a deep-seated, visceral reaction that seems to defy the normal rules of fear. It is part of the vasovagal syncope family. It is believed to be an evolved genetic trait. One theory proposes that this fainting reflex was a survival advantage for our ancestors in a world of brutal, close-quarters combat. In the midst of a violent confrontation, an individual who saw their own blood and fainted would have experienced a dramatic drop in blood pressure. This could have slowed the bleeding from a wound and made them appear dead to an attacker, who might then move on. What is today a profound inconvenience in a medical setting may be a ghostly echo of a time when collapsing in the face of wounding was a counterintuitive but life-saving strategy. The law of contagion is a form of magical thinking that can create fear and disgust. This is one of the laws of sympathetic magic identified by anthropologists, and it describes a deep, intuitive belief that once two things have been in contact, they continue to influence each other even after they are separated. This is why most people would be deeply uncomfortable wearing a sweater that was once worn by a terrible person, even if the sweater has been perfectly, sterilely cleaned. The object is felt to be contaminated by the essence of the person. This is not a logical fear, but a visceral one. It triggers the brain's disgust circuitry, the behavioral immune system, which is trying to protect us not just from physical germs, but from moral or spiritual contamination as well. It is the mind seeing invisible emotional residues in the physical world. The Tip X theory of memory suggests how we might unlearn fear by reopening the original memory. For a long time, it was believed that once a fear memory was formed in the amygdala, it was permanent. But new research has revealed a fascinating process called reconsolidation. It seems that when a memory is retrieved, it becomes temporarily unstable or unlocked for a short period before it is resaved. During this fragile open window, the memory can be edited. This has led to a new experimental therapy. A person is asked to retrieve their fearful memory, and then, while it is open, they are given a new, safe experience. This new information, this all-clear signal, can be woven into the original memory as it is being resaved. It is like opening an old locked document, editing a single word, and saving it again, a way of rewriting the past with the safety of the present. The overgeneralization of fear is how a specific bad experience can grow into a larger anxiety. This is a common and difficult aspect of fear. A person might have one single frightening experience, such as being stuck in a small, crowded elevator. The brain learns that specific elevator is dangerous, but over time, the amygdala can generalize this lesson. The fear begins to spread. It attaches itself first to all elevators. Then it might spread to all small enclosed decentralized spaces like closets or windowless rooms. Finally, it might even generalize to crowded places, like theaters or subways. The brain, in its zealous attempt to protect, has taken one specific data point and drawn a massive, all-encompassing circle around it. It is a process of association, where one shadow is allowed to stretch and cover a much larger part of the map, a quiet, creeping expansion of the world's perceived dangers. The opponent process theory of emotion helps explain the feeling of relief after a fearful event. This theory suggests that our emotional systems try to maintain a steady baseline balance or homeostasis. When one extreme emotion is triggered, such as a sharp, intense spike of fear, the brain automatically initiates an opponent or opposite process, in this case, a feeling of calm or even euphoria, to counteract it. This opposing force is slower to start and slower to fade. This is why, in the moments after the danger has passed, when you just narrowly avoided the car accident, you are flooded not with neutrality, but with a profound, almost giddy sense of relief. This is the opponent process, the brain's counterbalance, still running strong even after the initial fear has vanished, a built-in mechanism to gently and powerfully pull us back to peace. The emotion of disgust is, at its core, a fear of contamination. It is one of our primary universal emotions, and it is governed by a separate brain region from pure fear. The insula, disgust, is the guardian of the body's borders. It is the behavioral immune system that makes you recoil from spoiled food, bodily waste, or signs of disease. Its primary purpose is to make you avoid and expel anything that could be a source of infection. The characteristic disgusted face with the wrinkled nose and curled upper lip is not just a social signal. It is a physical act of self-protection. It is the body's attempt to close the nostrils to a bad smell and prepare to eject something from the mouth. It is a deep, primal fear, not of a predator, but of the invisible, microbial world that threatens us from within. The fear of failure, or phobia, is often a fear of the shame associated with it. For many people, the anxiety of trying something new and difficult is not rooted in the act itself. It is not the fear of the hard work, or even of the result not being perfect. It is a deep social fear. It is the fear of being seen to fail. This connects back to our primal need for social acceptance. To fail publicly feels, to the ancient brain, like a demonstration of incompetence, a moment that could lead to a loss of status, respect, and belonging. This fear of shame can be paralyzing, a powerful force that stops us from taking the very risks that are necessary for growth. It is the amygdala's fear of social rejection, misapplied to a modern world of personal and professional challenges. The white knuckle phenomenon is a physical manifestation of the body's preparation for impact. When we are on a turbulent flight or a speeding roller coaster, many of us have the same unconscious reaction. We grip the armrests with a crushing, powerful force, so hard that our knuckles turn white. This is not a conscious decision, nor is it a magical attempt to hold the vehicle in place. It is a deep, instinctual bracing response. When the brain anticipates a potential impact or a violent jolt, it triggers a massive full-body muscle contraction. Tensing every muscle is the body's last-ditch effort to protect its internal organs, stabilize its spine, and absorb the shock. That white-knuckle grip is just the most visible part of a much larger internal suit of armor, the body holding itself tight against the forces of the world. The pop-out effect of threatening stimuli is often tested using an array of simple, geometric shapes. This demonstrates just how fundamental our threat detection is, even before we identify an object. In these experiments, a person might see a screen full of circles with just one triangle pointing down, or a screen of neutral lines with just one that is sharply angled. People find the sharp or pointing down shape significantly faster than they find a gentle, rounded shape in a crowd of angular ones. The theory is that our brain is hardwired to associate sharp, angular, downward-pointing shapes with danger. These are the shapes of teeth, claws, thorns, or a weapon poised to strike. This pop-out effect is our visual system's most basic, primal filter, a pre-conscious bias for the simple geometry of harm. The fear of clowns, or coulrophobia, is a modern fear that combines several ancient triggers. Clowns are not an ancient evolutionary threat, so this widespread fear is a fascinating puzzle. It seems to be a perfect storm of unsettling cues. The Uncanny Valley is at play. The painted-on, permanent smile and exaggerated features look almost human, but wrong, creating a deep sense of unease. This fixed smile also creates a signal mismatch. The mouth is smiling, but the eyes might be neutral or sad, which the brain cannot easily process. Furthermore, the heavy makeup and costume completely hide the individual's true identity and emotions, which our social brain interprets as a potential threat. A clown is an unknown, unpredictable human, masked in a way that is designed to be joyful, but which accidentally triggers our most ancient warning systems. The auditory looming bias means that a sound getting louder is more frightening than one fading away. Just as our visual system is biased toward approaching objects, our auditory system is biased toward approaching sounds. When a sound is increasing in volume, our brain interprets this as a sign that the source of the sound is moving toward us. This triggers a much stronger, faster alert response than a sound that is fading, even if it is the exact same sound. This is a crucial survival advantage. An approaching sound is a call to action, a warning of an imminent arrival. This is why a siren that is getting louder is so much more arresting and anxiety-provoking than one that is fading into the distance. It is the brain's way of calculating a threat's approach, using nothing but the simple changing pressure of the air. The phrase, "scared to death," is a description of a rare, but real, physiological event. In a moment of extreme, overwhelming fear or emotional shock, the fight or flight response can become too powerful. The system can be flooded with such a massive, catastrophic dose of adrenaline that it is toxic to the heart. This surge of chemicals can cause the heart to stop or to beat in a wild, inefficient, and fatal rhythm, a state called ventricular fibrillation. This is not a slow decline. It is a sudden electrical chaos in the heart's muscle. This phenomenon, known as stress-induced cardiomyopathy or broken heart syndrome, is a profound and tragic testament to the sheer physical power of our emotions. It demonstrates that the connection between the mind and the body is so strong that an overwhelming signal from one can, in rare cases, silence the other. Fear of the evil eye is a widespread cultural belief that fear itself can be a weapon. Across hundreds of cultures and thousands of years, there exists a deep-seated belief that a look of envy or malice, the evil eye, can transmit bad luck, illness, or harm. This is a fascinating piece of social psychology. It is, in essence, a profound cultural understanding of the power of social anxiety and fear. It is a recognition that the negative, watchful judgment of others is a potent, dangerous force. To be the subject of envy or ill will from your community is to be in a state of social danger. The many talismans created to ward off the evil eye, like the blue nazar in the Mediterranean, are, in a sense, tools to comfort the amygdala, a physical object to soothe the primal social fear of being a target of another's ill will. And so, our journey through the ancient world of fear comes to a gentle close. We have traveled into the heart of an ancient mechanism, the quiet architecture of our own survival. We have seen fear not as a monster, but as a guardian, a sleepless sentinel sculpted by time. It is the amygdala's silent alarm, the body's sudden, powerful rush of adrenaline, and the tend and befriend instinct that calls us to pull together. We have explored the way a scream is built to be heard, and the way our eyes are designed to share a silent warning. These responses are not flaws, but deep, profound inheritances, a testament to life's unyielding commitment to itself, a story of protection written into our very nerves. We have also seen how this powerful feeling is woven into our world, how it can be passed down in quiet, invisible ink, and how our minds can learn to write new chapters of safety over old lines of fright, from the deep, primal fear of the dark to the complex, social fear of being seen. Each is a different shade of the same protective impulse. Now, we can let these ideas settle. Let them become part of a larger, calmer understanding, transforming this old, cold feeling into a simple, biological marvel, a complex and beautiful piece of our human story, now fading gently into the quiet of the night. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of fear and the gentle music carry you softly into rest. Sleep well. Good night.